Welcome back, everyone. Let's continue with working with this DC Metro data frame. And what we want to do is want to prepare some mini smaller data frames for each region, Virginia, Maryland, DC, West Virginia, and then plot them for ourselves. Let's go down and store the list of these unique, if I can spell, unique state values. So we want to create a list. So I'm going to take create something called a metro list, and I'm going to call DC Metro data frame. Take the states that we just had, and we call the unique method, and we're going to call the toList method to convert this to a list. And let's take a look at metro list. And we do have a list clearly indicated by the square bracket, and it is the four states or the metro areas that we want. DC is not a state, obviously. Let's take a look at DC Metro df.shape, by the way. Let's see what this looks like now. As you can see, we now have 260 rows followed by 246 columns, which is great. You might be wondering what happened because we added that extra column, but you recall we dropped a column too. We dropped size rank, so the number of columns remained the same. Let's go ahead and prepare for plotting. Subset of the data frame by state. All right. So I'm going to create something called DC data frame. This is for Washington, DC itself. We're going to call this data frame and call the lock to locate DC Metro DF state is equal to DC. And let's take a look at DC df.shape. I can see that out of the 260, 21 of these metro zip codes are in Washington, D.C. itself proper. In order to save time, I will simply copy and paste this, and I will change this to MD for Maryland. Of course, I will change this to MD, and this to MD. 118 of the metro areas are in Maryland. Let's go ahead and paste this again. This might be expected. We're going to have VA for Virginia, VA here, and VA here. 116 are in Virginia, and let's do West Virginia, WV, WV, and WV. And oops, lowercase. And 5 of them apparently in West Virginia. Well, that's pretty far from here. I'm not quite sure how they figured out that West Virginia can be part of the Washington metro area. It's over 60 miles away, but it is what it is. Let's go ahead and prepare a set of columns for plotting. We have 246 columns, but some of these we really don't need. So I'm going to create a columns variable, and I'm going to take cols 0:1. Now remember, this is going to basically fetch the first column, which is the zip city, which we created, and then we moved it into the first position. And we're going to append to this everything after column 8. We don't need the the city, the state. We don't need the rest of those columns. This is all we need. If I take a look at columns, I can see that, if I spell it correctly, invalid syntax. What did I do here? Oh, I forgot to put cols here. Sorry. If you take a look, we have zip city, and then we have the very first year that we have some data, 1996, April of 1996, going all the way to February of 2016. So these are the columns that we would like to plot against. I'm going to prepare state by state data sets for plotting. So I'm going to have a Virginia plot to be equal to the Virginia data frame with these columns. And we're going to have a Maryland plot. Let's just a data frame, MD data frame with these columns. I'm going to have a DC plot, which is the DC data frame that we just created with these columns, and West Virginia plot, which is West Virginia data frame columns. And let's do Shift Enter. I do want to take a look at one of these just for fun. So Virginia plot.head. And you can see that it shows all the zip city, that we had the zip code, the locality, and the state appended together, and then we have everything else, which is pretty cool. So that's what I wanted to do. What I want to do now is to use matplotlib to start plotting. It would be convenient to create a function, a Python function that we can just call, and we pass it the state data frame that we want, and or the state that we want, and then simply plot it instead of doing it individually. So let's create define. Let me put a comment here. Define a function for plotting. So def plot state. We're going to pass to it a state. First, we are going to print the state.shape. It's kind of cool. So we can see the columns, etc. Then I'm going to define a state that we was, this is not the same as that. That's going to be on the right-hand side. So this state is what's being passed. Remember that everything on the right-hand side of the assignment always gets executed and gets reassigned to the left. So we're basically renaming the state. I'm going to take state.setIndex to be zip city. So we're going to index these, order them, if you will, by zip city. I'm going to have a state variable, state tr for transpose, where I'm going to take the state that I just created and call the transpose method on it. I'm going to have a county list. Is going to be the state transpose dot columns dot values dot to list. We're going to have a figure, and this is going to be equal to plt, the matplotlib figure method. And now I'm going to define some variables here. Axis is fig dot add subplot. Now these values 111, etc., we're going to take a look at these. These make the graphs look, pudgier, wider, etc. And I just did a little bit of experimenting, and I came up with 111 being the best one. But our X label is going to be year, month. Kind of makes sense. And axis.set Y label is going to be median value per square foot. And then we're going to have a for loop for name in county list state transpose name, square bracket name, and call the plot method on that. I want to take this piece by piece so it makes sense. Before we even call these functions, let's take a look at some of the pieces right here. Okay, so first and foremost, I'm going to take, say, the Virginia plot, and I'm going to call set index, set index zip city. All right, let's see what this does. And you can see it actually indexes everything by zip city. That's what it did. Okay, I can see that I have this thing indexed by zip city showing up down here. What if I were to take this and add transpose to it? When I do the transpose, now you can see that zip cities are showing up on top right here. Very cool. What if I were to do dot columns dot, well, let's just do dot columns. And you can see that we get this. If I do dot columns dot values dot to list, I can see that I have this now showing up. The columns are showing up as basically this list. Okay, so there you go. These are all the columns, all the zip cities. That's in effect what we did up here. So I said set index zip city. Instead of putting it all in one line, I just did, state transpose is, and I misspelled transpose here. Let me do that again. So I'm calling state transport, and I created county list, which was to take that, then columns and values, that to list, and these are basically, I'm calling them county, although some of them are cities, they're not counties. But, whatever works best. So now that I have this, I am going to go, and instead of having to call the figure method and feed everything here into it one by one, I just split it into pieces and call then these various pieces by themselves. So axis is equal to basically this plot.figure. You would say plot.figure over here. Well, I didn't want to have to write that over and over, so I just did fig and then call the add plot method from that. So normally I would say plt.figure dot add subplot 111, but this is a bit more convenient in my opinion. Finally, we have this. We're going to loop through this county list, as you can see this right here, each of these, and we're going to call the state transpose name dot plot method. So we're going to get the transpose that we had. You just saw that. If I were to comment this out right here for a moment, what this does, it gives you the transpose with all the values, and this is something we can plot using matplotlib. So I'm going to comment this out. You can always uncomment it after I pose this and play with it. I'm going to call my plot state, and I'm going to feed to this the Virginia plot. And then I'm going to do plt.show, although usually it shows without saying that. But here is the state.shape. So we can see the Virginia plot.shape. If we had typed that in, it types it for us. Here is the median value per square foot, and this is the year month that we had. Each of these lines, it represents one of those 116 zip codes. Obviously, I can't tell which one is which, but that's not the point here. The point here is to see that back in 1996, you can see that they were going from around $50 per square foot to around 100 and maybe $70, $80. And then in the early 2000s, they started to mid 2000s, they started to increase. This 2008 thereabouts, you can see that there is a drop. Given where it was and given the drop, you can see it's still considerably higher than what it was literally less than 10 years or maybe 10 years prior. This is also what some people are referring to the gap between rich and poor. There's a lot more to it than that. It's not entirely correct in my opinion. But you can see that the housing prices for where the zip codes here remain more or less the same or went up just slightly, whereas some areas just skyrocketed. I mean, whatever this purple one is probably Loudoun County. It was $180, $170 a square foot, and it went up to over $500 per square foot. And this, by the way, is after the crash that it made it there. It made it there before that. It took a dip, not much, and then it went back up again. Let's take a look at plot state and check out Maryland. And plt.show. And again, you can see that it's very similar to Virginia. All of these are going to be quite similar. Again, it's more or less compact down here, $50, $49 thereabouts to about $180, $190, and then it just took off. It just skyrocketed. We know for a fact that people's salaries did not go up like that. That's for sure. Let's do DC itself. So plot state DC plot and plt.show. And there's Washington, D.C. with its, I think it was 21, yep, 21 regions. Again, very similar. You can see that some areas, the expensive areas remained expensive. It's just they skyrocketed. This one was around less than 200, and it went to about 650, approaching $700. And keep in mind, this is in 2012. That's the data set that I had. Now it's even higher than this, just as a comparison. Let's also take a look at West Virginia, because this one was the smallest one. So I'm going to plot state WV plot and plt.show. So West Virginia is interesting because you see that only one area was even considered part of the metro area, and it went up. And again, the scale is important here. Over here, we started at 50 or something in DC, and they went up to over 200. Even the lower ones, the ones that were a little bit higher, climbed considerably. Although this one is a huge rise, you can see it went from maybe around 30 maybe, to over 140, which is still percentage-wise pretty big, but then it took a huge dive and went down. And then we have some additional areas that are not considered part of the metro region that are showing up. So that's it. I just wanted to give you an idea how to work with another large data set. We will continue with these modules. We have additional data sets that we'll be working with. I hope you're enjoying these videos. If you are, please share them with your loved ones and people that are your friends. I'll see you in the next video.